Hello and welcome to this video on solving problems. So in this one we're going to be solving a bunch of different problems using our normal distribution. We're going to solve some where we just strictly kind of use the graph to solve, some where we use our calculator, and some where we use z-scores. So the first one, it says Glow Bright is the name of a 60-watt light bulb. The company tested 44 bulbs and determined that the mean life of the bulbs to be 900 hours and the standard deviation to be 50 hours. Based on the testing, they make a decision to produce 15,000 bulbs. So in part A, we are asked what percentage to the nearest percent of light bulbs will last between 850 and 900 hours. So what you should always do is start with your normal distribution, put all your values on there, and then see if you can just use that to solve. So our mean life was 900 hours. So I'm going to put that on the very middle of my graph. And then our standard deviation in this one was 50. So that was right here, standard deviation of 50. So we are going to be going up by 50 and down by 50. So this is going to be 950, then 1,000, 1,050, and then we'll go down as well. So we got 850, 800, and then 750. So we were asked what percentage of the bulbs are going to last between 850 and 900 hours. And those two are on our graph. So we can actually just use our graph and figure out what percentage that is. So I'm just going to shade the area. And this region, we had seen this before and we had it on our formula sheet. That was the region that was 34%. So our answer for this one is 34% of the light bulbs are going to last between 850 and 900 hours. Looking at part B, it now says how many of the bulbs produced will be expected to last between 850 and 900 hours. So I knew what percentage it was going to be. We had that right here. That was 34%. Now it's asking how many. So it wants like a value for the number of bulbs. Well, we knew they were producing up here. It said 15,000 bulbs. So 34% of the 15,000 is going to last between that 850 and 900 hours. So we have to take 34% of the 15,000 bulbs. And that's just equal to, our decimal of 34% is just 0.34. Of is multiply, and then 15,000 is just 15,000. And when we multiply that out, you're going to get 5,100. And then just don't forget, our units for this were bulbs because it asked how many. On to our second example here now. It says the volumes of bottles of juice are normally distributed with a mean volume of 1,000 milliliters and a standard deviation of 3 milliliters. And part A asks what percentage of bottles will have a volume between 995 milliliters and 1,004 milliliters to the nearest hundredth of a percent. So let's first put on our values onto our graph. So the mean was 1,000, so that can go into the middle. And then our standard deviation was 3, so it's going to go up by 3 and then down by 3. So again, this middle number, that's our mean, and then this would be 1 standard deviation, 2, 3 standard deviations, and then going down it's the same, it's just minus instead. So if we had to be between 995 and 1,004, that is not on our graph. So let's just plot approximately where they're going to be. So 995 is going to be, say, somewhere here. So I'm just going to label that 995. And then our 1,004 is going to be kind of just above the 1,003. So that right there is the 1,004. And we are going to be in between that. So I'm just going to shade. And now with this one, because it wasn't exactly on one of these points down here, we can't use just our graph. We need to use our z-scores. So we're going to have to find each of these z-scores. So we'll do the first one, we'll call it z1, and we'll do the 995. So we had to take the point, remember it was x minus mu, and then divide by standard deviation. So our x is the 995 minus mu, that was our average, which was 1,000, and then divide by our standard deviation, which was 3. And when we calculate that, you're going to get negative 1.67. Okay, and then we'll calculate our second z-score. We'll call this one Z2, and that was at the 1004. So it's going to be at 1004 minus the mean, 1000, and then divide by the standard deviation, which was 3. And when we calculate that one, you're going to get 1.33. So now that we have both of these z-scores, I'm just going to go to our z-score table and look up the percentages. So let's find negative 1.67. So negative 1.6 is right here, and then 7 is right here. So this is 0.0475, so that's going to be 4.75%. So we'll remember that and then write that back up top. Then we needed to find our other z-score of 1.33. So here's 1.3, and then 1.33 is right here. So it's going to be 0.9082, which that is, as a percentage, 90.82%. So let's go back up and we'll write those out. So this one gave us 4.75%, we had said. And then the other one, 1.33, that one gave out 90.82%. Now each of those we're measuring from that point and then to the left. So on our graph, each of these is measuring like that, towards the left. So if I want to find this middle region here, what I need to do is I need to take kind of this bigger one and then subtract off the smaller one to get rid of this area here, and then I'll only have left this area, which is the area that I want. So take the big one and subtract the small one. So we're going to go 90.82% and then subtract 4.75%. And when we do that, we get 86.07%. So part A is now complete. Part B, it asks, in a shipment of 576 bottles, how many would you expect to have less than 996 milliliters? So let's plot 996 milliliters. I've already got all my data written on this one. You guys, again, you'd have to write that out or just use the previous one that you already had. So 996, that's going to be kind of just below the 997. So I'm just going to label that 996. And it said we were going to be less than that amount. So we want to be less than that. We want to be to the left. So I'm just going to shade that region. So again, because this isn't exactly on one of these points here, we're going to have to use z-scores. So let's write out our formula. Z is equal to x minus mu divided by standard deviation. And then we can fill that in. So our x point was 996. Our mu was 1,000. And our standard deviation was 3. And when we calculate that, you're going to get negative 1.33. So now we can go to our z-score and we'll look that up. So here we got negative 1.3, and then we're going to have to go all the way over. So that is right here. So that is 0.0918. So it's going to be 9.18%. So that is 9.18% we said. And it didn't ask what percentage. Remember, it asked how many. So again, I got to figure out how many. So I got to take 9.18% of the total amount of bottles. And there were 576 bottles. So we got 576. So this as a decimal is going to be 0.0918. And then of is multiply by 576, and when we multiply that out, we're going to get 52.8768. Now with this value, we're going to have to make a decision on whether we should round up or round down. So if you had, say, 52.8 bottles, you don't quite have 53 bottles yet. So we're going to have to round this down, and our answer is just 52 bottles. So number 2 is all finished. Looking at number 3 here now. It says running shoes lose their shock absorption after a mean distance of 640 kilometers with a standard deviation of 160 kilometers. Zach is an elite runner and wants to replace his shoes after 25% of their natural life. at what distance should he replace his shoes? So what we're going to do with this one, and again with most questions, you should always start with your z-score table or your graph. So we're going to first plot on all our information. So our mean was 640. So again, mean has to go right in the middle. And then our standard deviation was 160. So we're going to have to add 160 all the way up and subtract 160 all the way down. And then I'm just going to plot on there our percentages. So if he wanted to replace his shoes after 25% of their natural life, we would have to kind of start at like 0% of the life has been used and then work upwards. So we're going to be adding these. So 0.15 plus 2.35 is going to give us 2.5. And then adding 13.5 gives us 16%. So we're working up to 25. And then if I would add on 34%, I would be to 50%. So that's too much. So I know I'm going to be more than this region, but I'm going to be less than that. I'm going to be somewhere in here. So to find where that somewhere is in here, we're going to have to use our z-scores. So we're going to look up our z-score, and the z-score we want to find is 25%. So 25% as a decimal is 0.2500. So we're going to have to go to our z-score table and we're going to have to look that up. So let's scroll down and we'll try to find 0.2500. So here we got 0.2514, and then we got to go down, but then it jumps to 0.2483. So out of these two, we got to pick the closest. This one is 0.0014 off. This one is 0.0017 off. So this one is actually a little bit closer than this one. So we're going to have to go with this one. So it's negative 0.6 and then scrolling up 0.7. So our z-score that we're going to use is negative 0.67. So that value that we just found, that was our z-score. So now I know what the z is, and what we're going to have to do next is we're going to use our formula that we've used from before. So we're going to use the z-score formula to calculate the distance. So z, I'm going to fill that in with what I just found, negative 0.67. The x, that is the value that we're looking for. That's the number for when he should be replacing his shoes. So that just stays as x. Mu, that was the mean life, that was 640 kilometers. And then standard deviation, we were told that was 160 kilometers. So now we have an equation where we just have to solve for x. So we got to isolate that x. The first thing we got to do, multiply on both sides by 160 so that this 160 will cancel down there. So on the left, when I multiply those two, I'm going to have negative 107.2 equals, and then I'll just have x minus 640. And then to get rid of this minus 640, I need to add 640. So do that on both sides. And then these two will cancel out. And so I get 532.8, and this is kilometers. Those are units for this. And that was equal to x. So he should replace his shoes after about 532 kilometers. It didn't say what we needed to round to, so we're just going to say 532 kilometers. The second part to this question is we're actually going to do it using our calculator. So it says solve using a graphing calculator. It says the inv norm can be used if we want to find a particular data value and are given the percentage, area, or probability. So our steps for using this inv norm, you're going to click second, vars, and then the inv norm button, and then you're going to enter the area, the mean, and then the standard deviation. And I'll show you how we'll do this on both of our calculators. So I'm just going to bring up my calculators here. So here are both my calculators. We got the TI-84 and then we got a older TI-83. Steps are very similar. This one, you just kind of got to memorize the order that you want to put it in. So what we're going to do is you're going to click second first, and then you're going to click vars, and then option number 3 there. That's what we want to go to. So you can either click number 3 or go down and click enter on number 3. Either of those work. And then it's going to ask for the area, the mean, and then the standard deviation. So the percentage of area that we were looking for was 25%. So you got to put in as a decimal 0.25. You can't put in 25 because then the calculator won't know what you mean. So we got in our area. Our mean was 640 kilometers. We were told that in the question. And then our standard deviation was 160. And then once you got that, you can just click enter, and then one more time, and then it'll find it. And that's what we had in our first answer. I'll just kind of move this out of the way. We had 532.8. This on our calculator, it's going to be a little bit more accurate than what we did with our Z-scores, but it'll be really, really close. So I'll show you how we can do it in the second calculator now. So you're going to click second, and then vars, and then option number 3 again. And then now you just got to memorize the order. So it was 25%, so 0.25, comma, and then our mean was 640, comma, and then our standard deviation was the 160. Then we can close our bracket and then click enter, and we can see that we got the exact same value. So either way, whichever calculator, even if you do it using Z-scores, you're going to get basically the same answer with all of them, just calculator is a little bit more accurate. So let's write down what we did to do that. We're going to put in those values. So the values that we put in was 0.25. Okay, can't be 25, it's got to be 0.25. And then the mean was 640, and then the standard deviation was 160. And that gave out our answer, which we got 532.08. Again, your calculator is just going to be a little bit more accurate. So that was our last question. Down at the bottom here, I'm just going to write out our homework questions now. And then just a couple quick notes about some of the questions. Number 15B, the answer in the text is actually wrong. It should be 37.79. And if you use your calculator, you'll get 37.81. And for 15C, the Z-score is actually right in the middle. So it depends on which value you pick. One answer in the back of the text will be correct, and then it doesn't list the other one that you could have got if you picked the other Z-score. So that is another answer that you could get.